So at this point, we're gonna work on solving oblique triangles. So last time we have done right triangles. This time we're gonna deal with oblique triangles. These are triangles that are either acute or obtuse angles, right? Now, there are two versions of law of sines, and here they are. The angle version tells us that the big letters or the angles should be on top. That means sine big A over small a, that's the side, opposite the angle A, equals sine big B over small b, equals sine big C over small c, right? Well, if you flip them, or it's reciprocal, then that's going to be your side version. Why do we have two versions in here? Simply because it's going to let us know whatever we are solving for. If we are solving for side, we want to use the side on top, okay? If we're solving for angle, then we're going to use the sign big A, big letters or angles on top, okay? Also, that would also tell us if we are going to use inverse sign or not. Typically, if you're solving for angles, then you might be using inverse sign values, right? However, if you're solving for side measurements, then you don't need to do inverse, typically, okay? Right. Now, there are three triangle cases that will be possibly, that can possibly be solved using only sine law. You don't need the other law, which is cosine law, right? Which are the following. Angle, angle, side. In short, you are given two angles and a side that is not in between those two angles, right? See this S or the given side, it's not in between those two given angles. That's AAS. Okay. Next one. If you are given ASA case, in short, you are given two angles and the given side is in between those two given angles. So that's ASA, angle, side, angle. Also, it might be the case that you will be given two sides and one angle that is not in between those two sides. That is called an SSA case. Okay? Now, let's see this particular problem in here, number 54, and how do we solve for this. So here it is. So let's first try to solve ABE in here and try to consider what do you think is our first step in here. So the first step basically in here will be what? Step 1 to solve. Labels, right? Put in labels, right? So in here, labels, we call them what? Big letters for angles, and opposite them will be what? Small letters will represent what? Sides. Very good, Kendall, right? So in that case, if this is big A, this is small a. We good, right? If this is big E, then this is a small e. Good. If that is big B, then this is a small b. How we good? Get it? Alright, so step 1, label. Big letters for angles, opposite them, small letters for sides. Step number 2. Well, we need to know what triangle case are we looking into, right? So let's talk about this ABE first. Let's highlight this. Triangle. Right. According to the given, what kind of triangle case is it? Well, let's see. That is an angle, right? So A, oops. That is another angle, right? Are we good? Right. That is a side, 4.2. But is this side in between those two given angles? No, right? Because the side that is in between these two given angles is this. But it's not given, so this is what? S, not in between those two given angles. Are we good? Right? So this time, we are considering the angle side case. Alright? Step number 3. Here it is. If two angles are already given, then we can solve for the third angle. Right? By what? Sum of interior angles. Right? Equal to how much? 180 degrees. Right? So any triangle, right? Oblique, obtuse, acute, any type of triangle should sum up to 180 degrees, right? So with that, what do we have in here now? Step number 3. Okay. Angle A plus angle E plus angle B is equal to 180 degrees, right? So angle A is given, angle E is given, therefore what do you think is angle B? Okay. Oh, do it on your calculators, right? 180 minus 48 minus 46. What did you get? Calculators. 86. Did you get 86, guys? Verify. We got 86 degrees, right? So where is that? Well, it looks convincing enough, right? For it to be 86. It's almost right. Right? Almost. Right? Okay. It's almost 90 degrees, right? Yeah, 86. Cool. All right. So it's pretty convincing, right? For that, right? So the step number 3. So we are done with the angles. Step number 4. What law of sines should we use? It depends on what? What are we looking for? Are we looking for sides or are we looking for angle in this case? Well, we're done with angles, right? So we're just looking for sides A and B, right? So with that, so you're using the what? The side version. So that means the sides on top. Are we good? All right. So what's the first one? Let's put it in here. A over sine A is equal to, now here's the deal. Are we going to use the B's or the E's? Well, we're going to use the one that has both side and angle given. So which one has both side and angle given? The B's or the E's? The E's, right? So we're going to use the E's, right? So in here, E over sine E. Good? Right? To solve for A. So what will that be? A over sine, what's big A by the way? 48, okay, is equal to, what's your E? 4.2 over sine, what's this? 46. Oops, 46. Are we good? Right? And step number 5 is to, well, definitely solve for the side, right? In this case, sides. Get it? Okay, so what's that gonna be? What we're gonna do? We just want A, right? How are you gonna remove the sine 48? Multiply both sides by sine 48, right? Very good. So multiply sine 48 here and multiply sine 48. So this will cancel out. Hence, we got our A. Are we good, guys? All right. So plug it in our calculator. What's that again? 4.2 sine 48 over sine 46. Right? So plug it in your calculators. What you're gonna get? Get it, guys? Good. Okay. Let me borrow this calculator in here. Good. Right? So I'm using TI-84 Desmos. That will work as well. First of all, second plus 712 to reset the calculator. Right? Since this is degrees, what you're gonna do? Click on what? Mode, right? Change that radians into degrees, right? Press enter. Make sure it's in degrees, right? Because it says in here degrees. Now, let's plug it in. What does it say in here? 4.2, right? Press sine. Press what's that? 48. Close with the parentheses first, right? We good? Divide. Where's that division? There we go. And then put in 1 again. Sine again, 46 instead, right? 46. And don't forget to close. Good, right? Press enter. And what value did you get, guys? 4.3. Right? Again, it says in here, nearest tenth. So we're going to put 4.3 for such. Are we good? Right? And do the same for the rest, right? So that means in here, so check for letter A. This is 4.3. Mr. Dilo, what about B? Similar to what you did, right? But instead in here, B's and E's. Get it? Okay, so let's plug it in here for B. What's that again? B over sine. What's big B? 86. Yeah. is equal to E again. We're using E because they have both given values, right? As much as you can, you are using the given values, not the solved values, right? Because the solved values in here, they have some round of error already, right? So make sure you are using what? Given values as much as possible, right? What's your E again in here? 4.2 sine, what's this? 46. So similar to what we did, what? Sine 86, both sides to get that angle in here, right? And that will be your side B. Are we good, guys? Right? Again, round it off to nearest 10 or 1 decimal place. Make sure it's in degrees, all right?